Negative and zero exponents. Numbers can be written in different forms. They can be written in an expanded form, an exponential form, and in standard form. 2 times 2 times 2 times 2 is an expanded form. The exponential form is 2 to the fourth. The standard form is 16. 2 times 2 times 2 is 2 to the third, which is 8. 2 times 2 is 2 squared, which is 4. 2, written exponentially, would be 2 to the 1, and our standard form is 2. 2 to the 0 has no expanded form, and the standard form is the number 1. 1/2, written exponentially, is 2 to the negative 1. 1/2 times 1/2 is 2 to the negative 2, which is 1/4. 1/2 times 1/2 times 1/2 is 2 to the negative 3, which is 1/8. And 1/2 times 1/2 times 1/2 times 1/2 is 2 to the negative 4, which is 1/16. So go ahead and look at the chart and see the pattern. When we're dealing with exponents, two of the rules we deal with are zero and negative exponents. When an exponent, when the base is to the 0 power, it equals 1. 2 to the 0 is 1. Exponents must be positive. So if we come across a negative exponent, we need to rewrite it as a positive exponent. So 3 to the negative 2 is the same as 1 over 3 squared, which is 1/9. As conversely, 1 divided by 3 to the negative 2 is equal to 3 squared, which is 9. So here we have the exponent in the numerator. To make it positive, we move it to the denominator. Here we have that negative exponent in the denominator. To make it positive, we move it to the numerator. Now the same principles apply with variables. We have expanded form, exponential, and standard form. X times x times x times x is x to the fourth, which is x to the fourth. So pretty much the exponent, exponential, and standard form for a variable is the same. So that makes it easy. X to the 0, anything to the 0 is 1. And then again, it follows the same rules for these fractions as written as negative. So the standard form would be the positive exponent. So again, anything to the 0 power is 1, whether it's a number or a variable. And exponents must be positive. So if I have x to the negative 2, I rewrite that as 1 over x squared. And 1 over x to the negative 2 is x squared. Again, moving the location makes the exponent positive. So here's your worksheet. Go ahead and simplify and look for a pattern. Definition of zero negative exponents. Let a be a non-zero number and let n be a positive integer. A non-zero number to the 0 power is 1. So a to the 0 is 1. So another example of that would be 147 to the 0 power equals 1. 2x squared y to the third to the 0 power is 1. Anything to the 0 power. Here we have the 0 power here. Everything inside gets multiplied to the 0 power, so it's 1. A to the negative n is the reciprocal of a to the n. So a to the negative n is 1 over a to the n. So 4 to the negative 2 equals 1 over 4 squared, which is 1/16. 2a to the negative 3 equals, everything inside here gets multiplied to the negative 3 power. So 2 to the negative 3, a to the negative 3 equals 1 over 2 to the third, which is 8, a to the third. So now we're going to practice. We'll do a and b together. 2 to the negative 2. So we can't have a negative exponent, so this is really written like that, 2 to the negative 2 over 1. So I'm going to move this to the denominator, and it's going to make it positive, which is going to be 2 squared. I have to put a 1 here to indicate that this is a numerator, and since I can go ahead and easily calculate that, I'm going to go ahead and write 4 instead of 2 squared. Negative 2 to the 0. Anything inside the parentheses is to the 0 power, so we know the answer is 1, because anything to the 0 power is 1. So go ahead and do the rest of them. Your answers for C and D. And remember, for D, some people get confused. We're not looking at the sign of the coefficient. We're talking about the sign of the exponent. So we only move negative exponents, not negative coefficients. So this was already written in standard form.